Hello everyone, welcome back to another video. If you are new to the channel, we aim to bring you useful content, and if you fancy that, make sure you subscribe to get notified when we upload a new video. With all that being said, today's lesson is about moles. It's a pretty big topic, so let's get started.
First and foremost, what are moles? A mole of a substance is the amount that contains as many elementary units as the number of atoms in 12 grams of carbon-12. The number of moles can be calculated by using only the relative molecular mass or the relative atomic mass, and the actual mass present of the sample. The equation goes like this: the number of moles is equal to the mass of the substance divided by the relative molecular mass. Or simply N equal M over Mr. If you want to calculate the mass of the substance present, you need to multiply the number of moles present with the relative molecular or atomic mass. Lastly, if the relative atomic or molecular mass is to be calculated, the mass of the substance present should be divided by the number of moles present.
Now let's learn about concentrations and how they are related to moles. The concentration is the amount of a solute in 1 cubic decimeter of solution. Concentrations can be written in grams per cubic decimeter or moles per cubic decimeter. The concentration of a solution can be found using the equation C equals 2 N over V, which means concentration equals to the number of moles divided by the volume of the solution in cubic decimeters. This equation can be used to find the volume when the concentration and the number of moles are given, and even to calculate the number of moles when the volume and concentration are given. Do note that the volume should always be in cubic decimeters, otherwise the calculation may go wrong.
Now, even though the volume of a solution can be found using the previous equation, have you thought of a way to calculate the volume of a gas? In fact, there is another separate equation to apply in order to calculate this value. Here it is. The number of moles equals to the volume of the gas divided by 24 cubic decimeters. If you guessed this, then you are correct. However, this theory only applies to gases in room temperature and pressure.
Now that we know the theory behind moles, why don't we attempt some practice questions? Here's the first one. How many moles are present in 48 grams of magnesium? Pause the video and calculate the number of moles. Did you get it? The answer is 2 moles, because the mass is 48 and the relative atomic mass of magnesium is 24. Therefore, 48 divided by 24 gives 2.
Next, what is the concentration of a solution which has 0.1 moles of a compound in 12 cubic centimeters? Before you start, make sure to convert cubic centimeters to cubic decimeters by dividing the value by 1000. Pause the video and give it a try. To get the answer, you have to divide 0.1 by 0.012, which gives us an answer of 8.33 moles per cubic decimeter.
Lastly, calculate the number of moles present in a gas of volume 120 cubic centimeters at room temperature and pressure. Again, don't forget to convert the volume into cubic decimeters. Pause the video and give it a try. The answer is 0.005 moles. This is calculated by first converting 120 cubic centimeters into cubic decimeters, which is 0.12. Then divide this value by 24, which gives us the final answer of 0.005 moles.
That brings us to the end of another lesson. We hope that you learned something new today. Please consider subscribing, and if you have any questions related to this lesson, please do ask us in the comments section below, and we'll see you in another video. Bye.